In this experiment, we will verify the condition for rotational equilibrium. So in rotational equilibrium, the rotation in clockwise direction would be balanced by the rotation in the counterclockwise direction. In other words, the torque in clockwise direction is equal to the torque in counterclockwise direction. So for this experiment, we need a ruler and a piece of string. So the first thing you will do is, this is like about a meter long string. So combine this like this, end to end, and then insert this end with the free side through the hole. And we will assume that this hole is at the center of gravity of this ruler. Okay, it may be slightly off from the center of gravity, but we'll still consider it to be center of gravity because it is more convenient to use the hole as the center of gravity. We can also tie on the outside, but if we tie on the outside, it may be shifted. So if it shifts, then it won't be very convenient. So we'll be using this hole for center of gravity. So we'll be using the centimeter side. So we'll tie this, or insert this free end through that, and then tie it like that. And then we'll hang this on some stand. Okay, you can use anything as a stand. You can use the handle on the counter cabinet as hanger, or you can use your chair as stand to hang this ruler, or anything. You will need to be a little bit creative in finding these kinds of things. Okay, so you need to find some kind of a stand where you can hang this ruler. Okay, now so you see that it's more or less balanced. That means we have this ruler in rotational equilibrium. All right, now we want to produce a counterclockwise torque. So by adding some weight on this side, and we'll be producing clockwise torque to counterbalance the counterclockwise torque. Okay? So we need to find a condition for which there's balance between clockwise and counterclockwise torque. So we'll apply some force on this side by hanging some weight. So weight in this case would be the bag and this sand. Okay, so we'll put some sand in this plastic pouch and then hang this weight using this hook. So we'll need to use some weight. So on the lab sheet, you are already given some weight on the either the clockwise side or counterclockwise side. Clockwise side is on this side and counterclockwise side is on this side, or you can say this is right side and this is left side. So on your lab sheet, you are given how much weight you want on the left side. Okay, so just an example, I don't know how much weight you need on the lab sheet. I'm just giving you some random example. So we need to put some weight on this side. I'm going to put in this case 20 gram on this pouch, 20 gram of sand on this pouch, plus the weight of this hanger. Okay, so for the measurement of the weight, I'm going to use this pocket scale to turn it on. When you turn it on, you will see 0 on that. So right now I have 0. Now I need to put 20 gram of sand, exactly 20 gram. Now I also need to measure the weight of this hook. Let's measure that. That's 6.5. So the total weight I'm going to use here is 26.5. So I'm going to write that on the force on the left side. Okay, so I'm going to use 26.5 gram. Okay, so we are supposed to use the force in newtons, but since we are just verifying the product on the left and right, so we don't even need to do the conversion. Okay, as long as both sides have the same units, we don't need to worry about the conversion. So we'll just express the force in this case as gram force. Okay, gram is mass, but if I call it gram force, then that's some kind of force. So our mass on the left side is 26.5, and so our center is not exactly at 15. Okay, this is 30 centimeter long, but it's not exactly at 15. So we need to consider where our center is. We need to first see the center. My center is, let's see, that's about 15.4, okay, 15.4. So it's 0.4 from 15, 0.4 to the right from the 15. That's our starting point. Now, if I put it at 13, if I put this hook at 13, then the actual distance would be 13 to 15 is 2, and 2 plus 0.4 is 2.4. Okay? If I put it at 12, then it will be 1, 2, 3, so 3.4. So I'm going to put it at 12. So that means the distance on the left side from the center of gravity is, again, so 12 to 13 is 1, 13 to 14 is 2, 14 to 15 is 3, and 3.4. Okay, so my distance is 3.4 centimeters on the left. So that's what I'm going to put on the left. Now for the right, I will use 40 gram of weight plus this hook. So let's see how much I have here. So I have here 40.2. I can remove a little bit sand from that. I want to make it exactly 40. Yeah, so that's exactly 40 now. So then you weigh this hook. So that hook is 6.5. So 40 plus 6.5 is 46.5. So my weight on the right side is 46.5 gram force. Now put this on the left, which is at 12. 12 is 3.4 from the center. And then now I need to find the point where I get rotational equilibrium, meaning I get the static condition where there is no net torque. Okay, so we need to, if I put it here, it tries to rotate. So I need to find a place where there is no rotation. There's perfect balance. So slide this until you get exact. See there. Now I have this rotational equilibrium. So it's not moving to the clockwise or counterclockwise, or to the left down or right down. So this is exactly at 17, but my zero mark is at 15.4. So from 15.4 to 16 is 0.6. Okay, up to 16 is 0.6, and from 16 to 17 is 1. So it's 1.6. So my distance on the right side is 1.6 centimeters. Okay, so that's how you find the force and distance for a particular equilibrium condition. Now you are given different weights on the right and left, and you'll be finding the distance on either right or left to find the equilibrium condition. Complete about 10 trials for this at different distances. Once you get all your data, so your job is to multiply D and F, that will give you the torque on the left side, and multiply D and R, that will give you the torque on the right side, and you will see if the right side torque is equal to the left side torque or not. Or in other words, if the clockwise torque equals counterclockwise torque or not. If they are not, then what's the discrepancy? What's the percentage discrepancy? Okay, so you need to get as little discrepancy as possible. Possibly if you could get less than 5%, that would be excellent. But if you get somewhere between 5 to 10, that's still acceptable. Okay? If you get more than 10, then there is something wrong with your trial, so you will need to redo that.